Okay, so thank you very much for bearing with us. I hope you can hear me properly. Let's start with a quick introduction. My name is Antoine. Many of you probably already know me. I'm a technical sales engineer for Seven Bel. And today we will be unboxing a sound scanner, making a measurement together, making a live analysis of such recording, generating a report, and then of course trying to answer the questions that you might have on our system. So those are the topics on the agenda for today. And without any further ado, let's jump into the unboxing part. So we will switch our cameras now so that you can see the device. So here's the actual carrying case that you would receive in case at some point you decide to acquire a sound scanner. This is how we ship our systems. As you see, it's a pretty sturdy case. On the inside, you will find, first of all, a very high quality Manfrotto tripod. This will work with all of the sensors that we currently manufacture and offer. The case will have space for two different sensors. The P132, you might remember it from a demonstration or from a previous webinar. That's our most standard and flexible sensor, going from 250 Hertz to 10 kilohertz. And then there's a P50 sensor, more portable and compact option, going from 700 Hertz to 10 kilohertz. You will also see the counterweights associated with each of the measurement sensors. This one's for the P50. A tablet holder and sensor holder. So this is the mounting part or bracket that will help you install the sensor into the tripod as well as the tablet. A calibration speaker needed to calibrate the device and to make an optical calibration so that the localization is optimally accurate. And last but not least, we will have the tablet included with each kit, from where you will make all your recordings, control the device, pilot the measurement, and of course also make the analysis, share the results, etc., etc. In each of these pockets, there are chargers, accessories, etc., including, for example, a laser distance meter. So you might remember that each of these sensors contains 5 microphones that you can see behind the foam. And by rotating them, we emulate about 400 virtual microphone positions, improving on the performance of traditional cameras by having a very good dynamic range available. Okay, so that's about it for the case contents. This was not shown previously, but it's mounted on wheels, so you can easily move it around and carry it around. And let's now switch to the measurement part. So let's first describe this setup through this slide that you should be able to see at the moment. I hope you can. All right, so I think you can see the slide now. In the setup right here, we're located in the meeting room. In the meeting room, we have the sound scanner setup looking at a partition that is causing some problems because some sound is leaking from the office next door. So we want to know exactly where the problem is coming from and where these leaks or particular transmission paths are located. And for this, you already all know probably the procedure. We place a source on one of the rooms, the sender room, and the receiving device in the receiving room. Usually the receiving device would be a sound level meter that you have to use in several positions, but in our case, we will use the sound scanner, which is mounted right here next to me. I hope that you can see it properly. And if we stop sharing the screen, you should be able to see it better. Perfect. You should also be able to see the sound scanner screen as we are currently streaming it into our computer. Give it 1 second. Perfect. All right. So this is the main screen of the acoustics application, which will be your main interface with our device. Here are all your projects stored. All the measurements that you did are stored in this main interface. You can access them even offline at any time by simply tapping on any project and opening it up. You can also arrange them in folders by categories, by dates, etc., rename them. And of course, you can also launch a new recording and start a new project. And for doing so, you simply need to turn on the sensor by pressing on the power button on its back. This is the sensor right here. Then press on the plus icon on the bottom right of your screen. And 3 measurement options should be available. The reflection, high speed, and standard. We will focus on the standard for today. So if I press on standard measurement mode, the tablet will detect the sensor nearest to it, in this case, the P132 sensor that is attached to the tripod. If I tap on its name, they will establish a connection. And as soon as we see this red dot in the middle of the screen flashing, it means that the system is armed and ready to start recording. Now we would make an image recording where the sensor will perform a couple of revolutions and only create one image, but we can also switch into video mode, where we can record for up to 30 seconds and have a video as the output in the end. So that's what we will use. Right here I have a control which will let me turn on the omnidirectional sound source on the other room. So if I press on this button, you might be able to hear the sound of the source, or Zoom's noise cancelling might prevent you from hearing it, but I will turn it on now. When I turn it on, I will also spin the sensor, make a 5 to 10 second recording, and then stop it and keep going. Okay, so I think that was enough. I can now press on the green check mark to validate the recording that we just made. If I wanted to discard it, I can tap on the red check mark. We should now give this measurement a name. So transmission, for example, and input the distance to the measurement object, in this case, the partition that we want to analyze. For that, we have included this laser distance meter. I just need to turn it on, press it against the measurement microphone in the middle of the sensor, and point it towards the measurement surface. In my case, this will be at 2.29 meters. Once I have input that, I can now select the maximum frequency for this analysis. We will leave this as 6 kilohertz, which is the maximum frequency when we are using video mode. This can extend up to 10 kilohertz when in single image mode. We can also select the frequency resolution between low, medium, and high. What this will determine is how many points your spectrum will have in the end, how well defined and how precisely you will be able to filter on your spectrum later on. And then the overlapping images parameter will let you create interpolated images between each revolution of the sensor, meaning that you will end up with a more fluid video in case you're trying to localize moving sources or sources that are changing their profile very fast. In our case, we have a very stable sound source. There is no need for any overlapping images and no need for any increased frequency resolution either. So we can simply press next. We can take a picture. And that's only for the thumbnail, so no need to worry too much about it. And now we can go back, press OK, and we find ourselves back into the analysis mode. Okay, so that went really fast. This project that we have just seen pop up here was already processed in less than 1 second, probably. And so the first thing we have access to is the time recording. I notice now that I made a very short time recording, but still, we have 2 frames that we can use. They both look very similar, so that means that the measurement is stable and coherent. So we can see each of these individual frames, or we can choose to average the recording. So if I tap on AVG on the top right, I can average the recording. I can select which frames I am averaging. And yeah, of course, we can also describe the acoustical image. So we see that there are 2 main sources at this stage. one near the corner, and one on the perforated panels near the left of the top. Okay, so we have now averaged our recording. We could have also played this video back. Let's keep the average for now. We can switch into the frequency pane and start performing some frequency analysis. So let's first increase this to its maximum range of 6 kilohertz. So by simply using these two cursors, I can select a specific range, and the image will adapt immediately to reflect the changes that I applied. So if I now select this specific range, for example, from 1.7 kilohertz to 6 kilohertz, we see that most of the high frequency noise is coming from the source on the left, on the perforated panels on the left, and we might also even have some reflections on the right side of the image, but they seem to correspond geometrically to the source on the left. If I take a look at the lower frequencies, we can go as low as 250 hertz for this particular sensor. We see that the energy is now evenly distributed between the source on the left and another source on the right. The last basic thing that we can do, and that we should always do when analyzing a recording, is to adjust the dynamic range. If we want to see the sources in a bit of a more compact way, if we want to reduce the size of the color scale on the right, we can simply reduce our dynamic range. And now we understand that the sources which are dominant in this particular scenario are these two. There seems to be a very, very close contribution of both of them at the measurement location. If I decided to increase the dynamic range, I might be able to see other sources at the cost of losing some definition in the sources that I already saw. So it's always a compromise, and you should play with it. Okay, so that's the basic tour of the application and of the measurement process. What remains to be done now is to create a report, for which we can tap again on these three horizontal lines on the top right, and tap on then generate report, which we can save to this device or share if we were connected to any sort of account, a drive, OneDrive, G Drive, whatever you are using. You can upload it directly so that your colleagues back in the office can start working on it, but you can also save it to this device. Let's tap on save, and then through the file explorer, simply go into the folder where you stored it and take a look at it. And well, what is displayed is basically the acoustical image, all the recording parameters, all the processing parameters that we selected, and the bandwidth at the time of creating the report, time interval, etc., etc. Also the reported levels, maximum contribution in the image, reference, microphone, total sound pressure level, dynamic range, frequency spectrum, and time signal. We could have also taken some notes, but that is secondary and was not necessary at this stage. This is a very clear and concise scenario. The last thing that you could do with this project is to actually export the project itself, bring it over to your PC and analyze it in the desktop software, which has a lot more capabilities in terms of spatial filtering, sound, power estimation, etc., etc. And also the report creation is quite more advanced. So that would be it in terms of what you can do. As you see, it's a very simple device to operate. In a few seconds, we made a recording. The setup process would have taken 2 minutes. And thank you very much for sticking with me, and sorry for the delay once again. Let's go to the questions and answers now. So you can type them in the Q&A box that you should see at the bottom of your screen, if I'm not mistaken. So feel free to go ahead and start typing your questions. Okay, so that's a good question. Any limits as to how close or far to the source you can be? There is a closeness limit. We usually recommend not getting closer than 50 centimeters. If you're trying to measure very low frequencies from a large object, that should also be increased to try and be not in the near field. But as long as you respect that, there's no restriction for closeness. And regarding how far away you can go, we have made recordings without any problem at more than 200 meters. So yep, that's not a limitation at all. The only thing is that you maximize the spatial resolution available to the instrument by getting close to your sources. So try to get as close as you can. Any other questions? Okay, we have one more.
The bar rotation motorized, or it's simply giving an initial push?
Yeah, so the bar rotation is actually manually operated. It is mounted on very low friction bearings. So as soon as I give it even the gentlest push, it will keep on rotating for a while. The recording length will be determined by how long the arm is spinning. We can also stop it manually, but if I stop the sensor, it will simply stop recording or continue to record for as long as the arm is rotating.
Calibration process.
Yep. So, okay, we didn't see the calibration process, but it would be quite easy. We simply have to place the calibration source that we saw before in front of the measurement system, so in the field of view, ideally in the near field, so 1 to 3 meters from the device. Make a recording. Let's see if I even find one right here. So this is what it would look like. That's the little calibration speaker that you saw earlier, placed at about 1 meter in front of the camera. You try to localize it, and if you notice that there is even the slightest offset, you can correct or compensate for it. So you simply go to Show Calibration Controls and move the source around a little bit to align the optical image and the acoustical image. So now if I press back, you get a pop-up saying calibration successful, and that offset will be applied to all subsequent measurements. Oh, oh yeah, sure. We can go ahead and do it. Oh, just on the screen. Yeah, sorry. All right. So let's say that we make a recording of this little speaker, and what we obtain is a source that's not centered on the speaker. So the speaker is right there in case you are not able to see it properly. So let's see that you try to record it and you see that the source is completely offset. Well, then you simply need to go and tap on these 3 horizontal lines, then on Show Calibration Controls, and tap on these arrows that popped up on the bottom left until you align the optical image and the acoustical image. This calibration process has nothing to do with levels or with the sensitivity of the camera. It only has to do with the positioning of the optical camera relative to the sensor. So we're just correcting for that and not for sensitivity problems. I hope that clarified it, and let's see if we have any other. Okay, we seem to be good for now. So just as a wrap up, you will get the recording of this webinar within 24 hours. It will also be uploaded into our website, and there will be a special promotion for everyone that participated into this webinar that you will receive by email along with the recording of the webinar. But in case you decide to acquire the system within a few weeks from this webinar, you will be eligible for a special promotion. So I really hope you enjoyed it. Again, sorry once again for the delay, and I hope to talk to you again soon. Thank you very much.